Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a Vitamix 5200. It's a really good device. It's more of an industrial device or more of a professional device. A lot of restaurants and places like that have one of these. Different variations, obviously. This is pretty old model, but it's very lively. It should survive many years if you treat it right. Now, what is wrong with this one? Actually, it does work, so the engine does work. The bearing has a little bit of play on it, which is too bad because I don't have the replacement for this, but we'll see. We'll probably open it and just see what we can do inside. I'm not sure how it opens, but we'll figure it out. But the base does work, right? It turns on. The speed control and everything is working properly, right? You turn it on here, you regulate here the RPM of the engine, and you have low and high speed. All right, very simple device, very simple design. But what's wrong with it is pretty common issue on these. So you do, say, smoothie, right, in this, right? If you put some ice and some fruits and stuff, you can do the ice smoothie. This is perfectly fine for crushing ice. You can also grind coffee in it. I also grind breadcrumbs in it. I make my own breadcrumbs. I don't buy panko stuff. It's not very good in my opinion. And plus, I grind the bread that I bake myself. So I just kind of like to know what I'm eating when it comes to bread products. But what happens with this is you do the smoothie, you put it on high RPM, and you keep it for, say, a minute, which is a lot. And the smoothie is hot. Why is the smoothie hot? The smoothie is hot because this bearing caught some friction. You can hear it. I'm not sure if you can, right? There's no play on it. It's not like the bearing is faulty, but it just has too much friction on it, which in turn creates heat, and in turn makes your smoothies hot, which is probably not what you want. So to counter that, we can order one of these. This is the repair set or kit, repair kit for this particular issue. And what we have is, we do have new, okay, I didn't even know. So we also have a replacement for this. Basically this, we're gonna take a look at it on the original one, but basically this is just when these teeth over here just kind of lose their sharpness, right? They just ground off a bit. What happens is that it's gonna just start making sounds like it's grinding like a grinder, basically, right? So that's when you have to replace this one as well. On ours, we're gonna take a look in a second, but it looks like it's okay on ours. And we have what we actually need. So this is not only new blades, not particularly sharp, but they don't have to be. Oh, this is really dull, but they don't have to be very sharp. But the main issue is the bearing. So now this one, you can't really hear it anymore, right? This one. So this is what's causing it to heat up. Along with this, you're gonna get one of these, very professionally opened. I don't see these as completely necessary, but the idea is that this can be difficult to open. So you just put it here like this and you turn. But I bet you that I can unscrew it without the tool. So what I do, I just hold it like this, right? One hand here, and I push. And there you go. See, I didn't need the tool. Now let's inspect the seal. Unfortunately, the replacement seal did not come with this kit. I think it should, but I don't see any problems with it. It's nice and rubbery. This is silicone, so this is good. Excellent. Because this is very important, because if it starts leaking through here, then you're in trouble. And now, let's see if we can do it without actually hurting ourselves. Okay, doesn't want to leave, so what I'm gonna do is I'm gonna start tapping on it a little bit, and it should let loose. There should be another seal over there on the other side. We have another seal over here, but the replacement should have a seal on it. Yeah, we have new seal, so that's good. Yeah, it's a lot of friction. I can feel it, and yeah, it feels like it's metal on metal, right? So there's probably a lot of that metal as a filed off, right? So there's like metal filings in there, and they are causing this friction. So let's replace it. This should be pretty straightforward. And let's put the second piece or the other piece over here. Catch it on one thread. There. Now for this, the tool actually is going to be useful, because you have to when the seal is new, you want to tighten it relatively tightly, because you want that seal over there on this side to just kind of squish in, right, to create a good seal. Again, if you don't seal it properly on this side, then you're gonna have some liquid going into the device, which is not ideal. I don't know what the exact torque should be on this. I'm just using my common sense. I don't want it too tight, because with this tool I'm capable of doing it very tightly, but if you do it too tight, then the plastic is going to break. Okay, that turns nicely. And what we're going to do is I'm going to fill it with water up to here, and put it in the place where I can see if there is nothing leaking. Then I'm going to do the same, but I'm going to turn it on. I'm going to put it to high RPM and do the same. Check if there's no drops, nothing wet on this side. But what caught my eye over here is this. This is melting. This is signs of melting. So in that case, it is a possibility that despite this being completely worn, it may not have been the main culprit. It still needed to be replaced, sure, but it may not have been the main culprit. Because if we have melting over here, that means that the bottom has heated up, and that heat transmitted into has been transferred into the liquid, which in turn means that we have a problem over here. Okay, I see 4 screws over here at the top over here. We just need to clean this as well. Yeah, this is supposed to be a little loose, and the teeth look good. I don't think they I don't think they're in desperate need of replacement, but since we have the new one, then let's replace it. All right, let's get these 4 screws off. We got some pieces falling out of it. Yeah, this is not supposed to be happening. Okay, so the first thing that we check is obviously a commutator. This is usually that's going to be the first thing that, actually no, maybe not necessarily a first thing that will fail, but one of the main culprits if it just plainly doesn't work, right? Then check the brushes, check the commutator. So let's get some light, some focus. Yeah, focus over here, focus here, and we can't really see much. I need a different light. Yeah, the sensitivity of this scope is really bothering. So this is one brush. The brush is okay. The commutator, well, so there are some things that you can do with this. So as you can see, we have a horizontal lines, right? That is normal. That will be happening eventually on every commutator motor because the brushes are moving across the commutator, right? What you don't want to see though are, if you take a look at the edge, right? You don't want to see on the edge, you don't want to see those little like cracks and stuff, right? Like little chips, right? Because if that happens, then the commutator starts eating away brushes a lot quicker. Then the brushes, instead of being smooth, are becoming like a grinding wheel, and it can destroy the brush holder, this thing, or it can destroy the commutator, or both. Once the commutator is done, then, well, there's not much you can do other than replace it. Now with this one, we could take it to my lathe and we could try to smooth it out. That is one thing you can do. You can also get yourself like maybe 1500 grit or 1200 grit, or no lower than, I would say, 6, maybe 800 grit. Put it on something very flat, meaning like a piece of something. Just wrap it around it. Put it on the commutator and start turning, right? Just to smooth it out. But since you're doing it by hand, you have to always turn it. Don't rub one side of the commutator and then turn it on the other side and turn it on the other side, because it's going to be uneven. Uneven commutator is going to create a lot of problems, and it might result in catastrophic failure. So let's see what we can do here. There's that little thingy to unscrew this, and we have only 3 seals over here instead of 4, unless I missed one. Oh, 3 seals. So these seals go over here on the side over here, right, on 4 sides, but we only have 3. So I'm guessing this has been opened. Oh no, there it is. Okay, there's the 4th one. But I'm guessing that this has been opened before and not put together as it's supposed to. Let's take a look at the board, just for curiosity. What do we have? I'm pretty sure you can get these boards as a replacement. You get the replacement boards, but looks like there's only one IC on the whole board, and there's one transistor here. You can see the legs of it, and this is the control transistor, and probably this IC. This IC is controlling this transistor, which in turn controls this transistor, which in turn delivers power to the motor. A very simple circuit. Let's see, can we read what this 10358? It tells me nothing. I don't know what this is, but I'm guessing some integrated circuit to control the motor. Pulse width modulator, something like that, most likely. And I don't know, I guess my microscope wasn't when I was talking about it, but we have this little transistor over here that controls this TH2 big transistor, and which in turn pushes energy to the motor. But now what I want to do is I want to replace this little thingy over here, and for some reason I do not see a little hole. There should be a little hole to disconnect it, but I don't see it, and there's no way to do it from the other side, or at least not that I see. Here it is. Okay, not took way too long to find. So take a look here. You see there's a little arrow here, and I noticed that on the replacement that's where the screw is. Right, here's the arrow, and that's where the screw is. So we know on this one that this is where our screw is, and that is just sealed over here. Not sure what's up with that, but let's get something and see. There. Okay, that's a little silicone, piece of silicone just pushed in here. So that was the whole issue. So now we should be able to just, well, now it's a little shifted, so what I gotta do is just knock on it from the back a little bit, because I removed it a little bit, but you can't remove it all the way without removing that thing. So let's try to push it back a little. See if that did the trick. Not quite, but I think enough to hold it, enough to get it, yeah. But it's not letting loose. There. Whew. And, let's take a look at it under the scope. So as you can see, it's far from perfect, and you can see that it has seen a lot of work, right? They are a little shaved off over here. Now let's see the replacement. That looks a lot better. Okay, so now let's, before we put it on, let's see it over here. So we have two bearings. On every motor, you're gonna have pretty much two bearings, one on at the top, one at the bottom, right? And these are what holds the motor and the rotor in place. It doesn't look bad to me. Actually, it sounds okay. It feels okay. I don't feel any play. And usually when you start turning like this, right, if there are any pieces of broken metal in the bearing or anything like that, you should feel that there's going to be different friction. It's kind of like safe cracking, right? There's going to be different friction. Right now, all the friction that we feel over here is from the commutator. The brushes are pretty much full. How do you tell? It's actually pretty simple. So this is the brush, right? And this little, I need a third hand. This. So you see the wire comes in here, and as the brush is eaten away, this wire will be moving across this groove over here all the way to here. And when it's nearing here, that's the time to replace the brushes. But as you can see, these are almost new brushes. They're pretty much exactly the length of the brush holder. So based on that, I conclude that first of all, we don't need to remove or replace the brushes, and we don't really need to do anything to the commutator. If there was something actually wrong with the commutator, we would see abnormal use of the brushes. They would be very short at this point, and they're not. So I conclude that the brushes are fine and the commutator is fine. Now, could you just put WD-40 on it? You could. We used to do that back in the day. There are better chemicals designed for cleaning the commutators. I have a little bit of deoxide over here, but we're gonna use the golden rule. If it ain't broke, don't fix it. It's definitely a good rule to have. The cable management is not the best here, but it's all right. Now let's grab the new bushing or whatever this is, and let's put it on. Actually, no, I don't need to. First, I'm going to put it together because it's much easier to put together right now when you can freely put this on. Because once you put this bushing on, if the motor slips from these holders over here, it's difficult to put it back. So it's going to be easier to just put it back together like this. Okay, everything's good here. Does it go this way or the other way? This way. there's no way to put it the wrong way, so we just have to find where it fits. Okay, looks like by accident I rotated the motor 90 degrees. That's why it wouldn't fit. Now it fits perfectly. So it's kind of hard to tell which way it should be here once you disassemble it. It is rectangular, so you can rotate it 90 degrees and that's no problem. But what you have is you have these two notches over here, and inside you have these two, right, on this side and on this side. So if you rotate it 90 degrees, then it's not going to fit with these. It's just going to block here on here, right? So that's how you can tell. I'm kind of learning as I go as well, because I've never disassembled this particular device, but I've done so many of these. I worked in the company that was just recycling stuff basically. But as you know, if instead of recycling, if you can resell it as working device, then you make decent money, right? So I was in charge of fixing the devices, or I was just tasked with fixing the devices. And I would specialize in printers, but I would do a lot of these things because they usually would come in with no brushes or faulty commutator or electrical issues, right? So if you have a whole pile of these devices, then you can make a lot of them. Just mix and match parts and make them work. And if you don't, it's no problem. Okay, so now let's put these all on. And one more here, and one last one on this side. Okay, now let's flip it upside down, confirm that the screws or the holes are aligning. Let's try first one and see. Okay, we've lost some footage because my microphone died. I don't know when, but what are you gonna do? Okay, there's a lot less play on this bearing now, on this bushing, so it should work a lot better. And now let's confirm that we don't have play on it anymore. And the way to confirm that, we're going to turn it on, make sure that it is off before you plug it in. One time it happened to me, there were stuff on it and it was set to the absolute maximum. I plugged it in and it just started roaring and throwing stuff all over the shop. So it's simple and intuitive and kind of a common sense to do that, but until you mess it up and forget to check, then you always remember. Not before. Okay, now so now we're turning it on, right? Don't touch it, don't play with it. It's very powerful. You don't want to lose your fingers or do any damage to yourself. And now what I'm doing, yeah, I can tell already it's much better now. So I'm speeding up and slowing down, right? And I want to hear nice and steady frequency that you can hear, right? The sound going up, smoothly going up and smoothly going down. Now if you do this and it's not as smooth as this, I wish I showed you that before I replaced it. It makes sounds like it's grinding down. It's not smoothly going down, it's just kind of grounding down. So it's uneven, right? Yeah, this is what you want to hear. Yeah, beautiful, smooth transition down. Perfect. Not much goes into this. Now, so the overheating should stop on all fronts. Let's see if we can put this on. Now I don't have the rubber yet because I want to clean it first. I just want to confirm. It sounds a lot better. It sounds much better than it did before. And I think this is it. All right. I'm not gonna put this on yet because first I wanna clean it. But obviously I'm not gonna bore you guys with cleaning because that's nothing interesting. And since it's been used in the kitchen, this is what it looks like. That's why I always use gloves when I work on these. Alrighty, there we have it. A Vitamix 5200 repair. Very easy, as you can see. The replacement parts pretty cheap. This is below 20 bucks for this whole kit. The tool can stay for further repairs. The next time you don't have to get the tool. Next time you can just get the bearing and the bushing over here. That's it. Hope you found this useful. Thank you very much for watching, and I shall see you guys in the next one.